Welcome back. Change of scenery, I know. So let's continue on. Let's talk about the fourth transgressive regressive sequence called the Absaroka sequence. If it will work. Let's try that again. Here we go. Okay, so kind of at the beginning of the Absaroka, we have still some water, craton, water. Let's see here, water, craton, water. Close enough. And then at the end of it, that brings us to the end of the Permian, the end of the Paleozoic era, and that's kind of where the time frame stops. So, this sequence includes rocks deposited in the Pennsylvanian through the Jurassic period, which is actually tiptoeing into the Mesozoic. As you can see, the Absaroka, we have a transgression, regression, then it transgresses again before it regresses. So we have some of it that we'll talk about in a later unit when we talk about the Mesozoic era. But we'll kind of stop right around this portion. That's what that says. The unconformity separating the Kaskaskia and the Absaroka sequences essentially divides the strata of North American sediment and sedimentary rocks into the Mississippian and Pennsylvanian systems. Go back to that right here. So the kind of, again, the unconformity between the Kaskaskia and the Absaroka is kind of what serves as the boundary between the Mississippian and the Pennsylvanian. That becomes important in just a second, because those terms, the Mississippian and the Pennsylvanian period, we typically only use in North America because we saw a little bit different geology than the rest of the world. For instance, in Europe, they just call the Mississippian and the Pennsylvanian combined the Carboniferous. So our Mississippian is like the lower or older part of the Carboniferous, and our Pennsylvanian is the younger or upper part of the Carboniferous. So just, you might hear Carboniferous to cover the two, or Mississippian and Pennsylvania. That's what we prefer in the good old United States. So as this transgressive regressive system is working, this is kind of what we're seeing in the North America. More on the Antler Highlands, more on the Ancestral Rockies a little bit later, and we'll get more into the Appalachian Mobile Belt mountain building events. But some of the most important, I think, rocks that come out, or the most important things that come out of this time period, are going to be these coal swamps. And these coal swamps serve a very big purpose, and they are kind of a big reason we are the country we are today. So let's talk about something called cyclothems. It's a cyclical pattern of alternating, not just usually marine sediment, sandstone, shale, limestone, but that's marine, that forms in the shallows of the ocean, but marine and non-marine strata. And that's very characteristic of Pennsylvanian period rocks. The repetitive sedimentary sequence that includes marine and non-marine rocks are called cyclothems. This usually occurs in areas of low relief, flatter areas, and again, they become very, 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 very important, especially the non-marine units of the cyclothem, the sediment that was deposited not in the shallows or depths of the ocean, but more on dry land or fresh water. The initial deposits of these cyclothems represent deltatic deposits, river deltas, and fluvial deposits, river deposits, so freshwater deposits. And above them is usually kind of a layer of clay that contains roots from plants and trees. And then in a layer just above that is the layer of coal. This is why these cyclothems become so important, because the layers of coal are very common in this odd transgressive regressive series of non-marine to marine and back sediments to sedimentary rock. The coal beds, the way coal is a fossil fuel, it is a rock, but it is formed from biological material, because coal beds are actually the accumulation of plant material, usually that have fallen into swamps. and here comes the swamps, the reason why they're so important. A swamp is an area of water that doesn't really move around. It's kind of stagnant. Swamp. That's why so many things are funky in a swamp. So the water doesn't really flow around like in a river would. So it's water that's kind of just there. And anything that dies or decays, leaves, plants, trees that fall into the water, kind of settle down to the bottom of the water. That builds up over time. And if that builds up over time, additional sediment on top, especially if we're in one of these Cyclothem transgressive regressive series where sediment's being deposited, then that organic material gets compressed over time and turns to coal. Coal is actually fossilized plant material, old plant material. So how does this look? So if we're looking at a Cyclothem series in a sequence, so we have transgressive events, so we go from terrestrial sediments, so Aeolian sandstones, things like that, river sand sediment turning to sandstone, and then a clay layer, and then we get to finally the coal here. And then it continues into marine sediments, maybe marine-based sandstone, shales, limestones, and then back again. But the important part is this coal coming from these swamps. All right? Here's a layer of coal in some Pennsylvanian age rocks coming from this transgressive regressive series. So again, these coal swamps, they're usually at the boundary of the ocean, but they're still freshwater environments, more terrestrial environments. But as the sea is transgressing and rising, that goes further and further inland, and then it gets overlain by marine sediment. So we have terrestrial sediment, coal, marine sediment. So a little bit about how just coal forms. Again, you got swamps, plant material, that dead material falling, get overlain by additional sediment, more sediment, more sediment. So you get pressure and a little bit of heat, and eventually that organic material gets compressed into coal, which is a rock. And there's actually different types of coal, FYI. So just general swampy environment, all that organic material as it's piling up at the bottom of the swamp, it makes something called peat. Peat, if you apply a little bit more pressure, maybe from overlying sediment, it turns into a very low-grade coal called lignite. Additional heat and pressure from more overlying sediment turns lignite into bituminous coal, and this by far is the most common type of coal. This is a lot of what we mine here in the United States, North America. And then in the rare case, with a little bit more heat and pressure, if we metamorphose that coal, which is bituminous coal, which is a sedimentary rock, we actually get a metamorphic rock called anthracite, anthracitic coal, which is very high-grade coal, kind of rare to come by. I want to point out kind of these folded anticlines and synclines. All right, this is folded up sedimentary layers. And here's the coal layer that got folded up. This happens at areas that there's a lot of heat and pressure, like at convergent boundaries, like, I don't know, when continents are colliding. More on that in a little bit. So as far as what we'll look at in the Absaroka, that kind of brings us to the end of this transgressive regressive series. Again, the big thing here in this sequence is those cyclothems and those coal deposits that we start to see. What's happening in Arizona? More deposition, more deposition, more deposition. Yep, more deposition. We have some other stuff going on here with the antler orogeny, which we'll talk about here momentarily. But when we're looking at the Grand Canyon, the top of the Grand Canyon, the layers, as far as what major sedimentary sequence is involved at the top, is the Absaroka sequence. So when we're looking at the Grand Canyon, if you ever go there and you're looking at all these layers, these are all the sedimentary layers, all Paleozoic era, all from about 540 million years ago during the Cambrian to about 240 million years ago to end the Permian. These are all sedimentary layers from the Paleozoic era that were deposited during these major sequences: the Sauk, the Tippecanoe, Kaskaskia, and the Absaroka. Thank you, Grand Canyon, for showing us that. So let's go ahead and pause there. When we come back, we'll talk about that thing I just mentioned, the antler orogeny. I'll save a little bit of information for when we get there. So I'll pause here. I'll see you in a second.